January 17, 1944. The air over the Reich was a symphony of destruction, a sound that, for 3 long years, had been steadily growing in volume and menace. Yet, on this isolated stretch of frozen farmland near Oldenburg, in northwestern Germany, the sound was one of eerie silence, broken only by the scrape of shovels on packed snow and the heavy breathing of a recovery crew. Oberstleutnant Erich Schlieper, an engineer whose life had been measured in the precise tolerances of machine tools and the unwavering rigidity of German steel, stood before a mangled testament to an American pilot's final desperate flight. The field was a ruin. A massive, olive-drab shape lay half-buried in the mud, its 3-bladed propeller twisted into a metal helix of modern sculpture. This was a Republic P-47 Thunderbolt, an aerial beast known to the Luftwaffe as the Jug, an affectionate, if grudging, nod to its immense barrel-chested bulk. The pilot had bailed out safely, only to be captured moments later. But the machine itself, for Erich and his team from the Erprobungsstelle Rechlin, the Luftwaffe's central testing center, was the true prisoner. It was a tangible piece of the enemy, and they were here to dissect its secrets. Historical context: the year 1944 was meant to be the year of German air superiority renewed. The rhetoric from Berlin still promised wonder weapons, the sleek, swift jets of Messerschmitt and Arado, aircraft built from the abstract poetry of speed and lightness. The Bf-109 and FW-190, legends of the air, were paragons of the German design philosophy. Elegant, swift, and designed for the maximum effect from minimal mass. Every ounce was optimized for climb, speed, and maneuverability. They were precision instruments, built by a nation obsessed with efficiency and blitzkrieg, the fast, decisive blow. But the war had stalled, then turned. Now, their enemies were not merely resisting. They were manufacturing. The tide of aluminum flowing from American factories was not a trickle, but a deluge. This vast industrial capacity was becoming manifest in aircraft like the P-47. Since its debut in European skies in late 1942, the Thunderbolt had been a persistent, infuriating problem. It was a fighter that seemed to disregard the basic laws of aerial combat physics as understood by the Luftwaffe. It was not the fastest, nor the most nimble, yet it returned from missions riddled with holes that would have shattered any German machine. It simply refused to die. For Schlieper and his generation of engineers, raised on the gospel of German scientific supremacy, the American air campaign felt less like a contest of skill and more like a crushing, indifferent weight. The strategic bombings were not just destroying factories, they were destroying the very confidence in the superiority of the German machine. This captured P-47, therefore, was not merely a technological study. It was an attempt to understand the enemy's heart, to find the flaw in their overwhelming strength. Emotional contrast: the German pilot, honed by years of rigorous discipline, soaring in a fighter built on a philosophy of precision and economy, expected to find a machine that reflected the crude, mass-produced image of its American maker, heavy, clumsy, and perhaps simple in its engineering. They anticipated complexity, but a complexity born of haste, not of refinement. They expected to find a weakness, a corner cut, a sign of the American obsession with profit over perfection. Instead, when Schlieper's team hauled the wreckage back to a darkened hangar near Rechlin and began the painstaking process of disassembly, they met an industrial philosophy utterly alien to their own. What they expected was a machine. What they found was a tank that could fly. The first shock was the sheer scale. The Thunderbolt was colossal, weighing nearly 10,000 pounds when empty, almost double the weight of a standard Bf-109. This weight was not wasted. It was protection. The pilot was cradled in a bathtub of hardened steel, shielded by a seemingly gratuitous layering of armor plate and bulletproof glass. The second shock was the engine. The Pratt & Whitney R2800 Double Wasp was a behemoth of 18 cylinders arranged in 2 radial rows, producing over 2,000 horsepower. It was not just powerful, it was redundant. Its oil lines, fuel feeds, and cooling systems seemed to have backup systems for their backup systems. This was not the lean efficiency of the German V-12. This was a brute force approach, an engine built not to be the most refined, but the most survivable. This concept of built-in redundancy, of engineering not just for performance, but for overwhelming survivability, flew in the face of everything the Luftwaffe taught. German doctrine favored speed and agility to avoid being hit. American design embraced the philosophy that it was better to absorb the hit and keep fighting. The Luftwaffe designed a fencing foil. The Americans built a sledgehammer. Symbolism. The 8 barrels as the engineers peeled back the cowling. The true, unsettling symbol of American industrial excess became clear. The 850 caliber Browning machine guns. Each wing housed 4 of these heavy barrels, a total armament that was almost absurdly lavish. In German fighters, armament was a considered balance. 2 cannons and 2 machine guns, or perhaps 2 of each, carefully positioned and optimized to deliver a concentrated burst. The emphasis was on accuracy, a short, precise, surgical strike. The Thunderbolt carried a spray of firepower. These 8 guns could fire nearly 100 pounds of ammunition in a minute. When the American pilots flew their long-range escort missions, they were not given the precise instructions on ammunition conservation that were drilled into their Luftwaffe counterparts. They were given abundance. The ammunition belts, which the German team had to painstakingly unspool and catalog, seemed endless. The 50 caliber round, heavier and more destructive than anything the German aircraft carried in similar quantity, became the recurring symbol of American power. It represented not the cleverness of its design, but the sheer industrial capacity to waste rounds until the target was simply annihilated. This was not a weapon. It was a fire hose of steel and lead. It was democracy in its industrial form, overwhelming, loud, and unconcerned with finesse. Historical evidence, the reports filed by Schlieper's team to the Reichsluftfahrtministerium, RLM, betray the professional shock of the engineers. A specific evaluation, marked secret, concerning the damage tolerance, included a stark confession. The machine exhibits a structural integrity beyond anything anticipated for a single-engine fighter. The engine mountings alone could withstand a force equivalent to a moderate direct hit from an anti-aircraft shell and still function. This was backed by data. A key observation was the complexity of the turbo supercharger system. The P-47's enormous belly was not just fat, it was functional, containing a labyrinth of ducting and an exhaust-driven turbo supercharger that allowed the double Wasp to maintain its monstrous power output even at altitudes over 30,000 feet, an altitude where German pilots, especially in the early war, felt safe. One RLM analysis noted, "The ductwork alone is a greater use of light alloy than an entire Me-109 structure. This is a design born of resources without limit." Another captured document revealed the American pilot training manual's emphasis on the P-47's diving ability. The aircraft's weight, its weakness in the slow climb, became its devastating strength in a dive. It could plunge from high altitude, gathering speed to chase down any German opponent, and its structure, robust, heavy, and over-engineered, could withstand G-forces that would tear the wings from a lighter German design. The engineers were forced to conclude that the Americans had taken what the Germans considered a flaw, great weight, and turned it into a decisive tactical advantage. The captured Thunderbolt showed the German engineers that the enemy's strength lay not just in its factories, but in its willingness to sacrifice the pursuit of theoretical perfection for the certainty of massive, durable execution. Schlieper's final summary, tucked into the Rechlin files, was the ultimate admission. "We have built a faster machine, a more elegant machine, but they have built the machine that returns, The philosophy of this aircraft is not speed or maneuverability, it is survival. This is the first fighter we have examined that seems designed to lose half its systems and still carry its pilot home. It shows a complete disregard for material cost in the service of the pilot's safety, a luxury we cannot afford. Transformation, the examination of the Thunderbolt, marked a psychological and ideological turning point for many of the engineers who saw it. It shattered the illusion of German technological invincibility, an illusion carefully cultivated by the propaganda ministry. It forced them to confront the reality that the war was no longer a battle of engineering genius versus engineering genius, but a confrontation between a nation struggling with acute resource scarcity and a nation operating in an environment of limitless industrial freedom. Tadr, aesthetic superiority of the Luftwaffe. Machines, their clean lines, their speed, their efficiency, suddenly seemed hollow, a kind of structural vanity. The P-47, with its ugly bulldog appearance, its sheer, blunt functionality, was the more honest machine. It wasn't designed to look good. It was designed to win. And more disturbingly, it was designed to ensure the man who flew it would be back in the cockpit tomorrow. This focus on the individual pilot's survival, a byproduct of abundance, was an insidious poison to the German doctrine of sacrifice for the whole. The Thunderbolt taught them a brutal lesson. Quantity has a quality all its own. The engineers who once prided themselves on squeezing the last few kilometers per hour out of a light airframe were now forced to draw up plans for a new, heavier generation of fighters, incorporating armor and redundancy, a reluctant, bitter admission that the American way of building was the way of the future. The ideology of the Übermensch machine, the swift and perfect strike, was being crushed under the physical weight of American mass production.